This is another application of string formula, a simple interactive conceptual cost estimate model. This is a conceptual cost estimate with definitive cost estimate output. A conceptual cost estimate is important during feasibility study, and you need this kind of model to deliver a timely cost estimate with definitive output. Therefore, you can mitigate the risk for getting toasted during the design development and pre-construction planning. I used to work in an extreme fast-paced retail industry, managing the capital cost for store development from conceptions till the project closures. And at the peak, we were opening more than 100 stores a year for 4 business units, big and small. But the feasibility study effort during the site selection was way more than that. Probably for one store that was opened, it was already gone through at least 10 times feasibility study effort or 10 times cost estimate. Meanwhile, the business development process for feasibility study were beyond my control. As far as I can recall, we literally received requests for capital cost estimate almost every 10 minutes. That was the first time the idea of developing the cost estimate model popped up to resolve that issue. I'm not going to elaborate further on how to build the cost model and how to utilize the model as a tool, because it will take much longer time to explain and much more complex discussions. So let's stick to the agenda of this recording. In this simple cost model to estimate the direct cost for construction of covered walkway, I have the design and technical parameters entries in the green cells. This cell D34, I use string formula to automate the covered walkway descriptions based on the designs and technical entries above. It may look complex, but actually this is a very simple text combinations, simply using the string. And lastly, in this box, is a simple automatic cost estimate report as generated by the model. Again, this might seem a little complicated formula. It is actually a simple string formula combining the text and converting numbers to text format using the fixed formula. Let me demonstrate how this cost model will interact based on the various entries. First of all, I am going to split the screen. And then cut and paste the cost estimate report in another worksheet. So let's change the data entries. Oops. Let me do the cut and paste. Therefore, then we can compare. Okay, let's change the entries. Say, change the length of linkway to 60 thousandths and length of covered walkway to 40 thousandths. And I'm going to pick flat metal roof this time and change the support and the frame, the roof frame to galvanized steel. Now I'm going to change the column to column distance as well. And I presume this will be very light, so I pick the smallest foundations. And here's the report. So you can see it is automatically changed. Let's try another one. This time I'm going to pick pitch roof tile with the painted steel support and roof framing. Then I'm going to change the column-to-column distance and the column height. Then I change the overhangs to 3 feet instead of 2, and roof angle 30 degree. And I presume this will be very heavy, and then I pick the largest foundations. So here's the report. As you can see how effortless it is to generate a definitive cost estimate from this model. If you work in organizations with similar problems that I faced before, conceptual cost estimate model like this is a great solution. And if you'd like to find out more, send me an invitation on LinkedIn and let's get connected for further discussions.
Thank you for staying with me. And as mentioned earlier, I'm going to show you in this box on how to use the string formula to automate the backtest report. This is the draft I have prepared in advance, and I'm going to automate this draft report to say that the backtest result against the same data for these equations as shown in row 7 as level 0, 0 in the cost estimate model has shown that 55% of the estimate were not underestimated. However, with the 10% contingency, the same backtest resulted that 27% of the estimates were underestimated, or then 1 minus 27% will be sufficiently estimated. So let's do it. So now I'm combining the equations. Then the 55% and the contingency 10%, and this is the result of the backtest, or 1 minus 27. So let's see. As you can see, this report does not seem right. Therefore, we need to fix it with a fixed formula and also display the contingency percentage as a positive value. So let's try again. So I'm going to fix this with a fixed formula, times 100 to make it round. And then I'll choose 0 decimal and 0 for no comma, because you don't need commas for 100%. And because the contingency is in negative value, later on I'm going to make it positive with the ABS formula. So I'll do the same things for the backtest result percentage. Okay, now let's try it again and see. This is look right already. That's all for this recording. I hope this is useful and you all have a great time. If you'd like to discuss a solution for your cost management process, let's get connected on LinkedIn. Thank you for watching and happy creations.